This is Lab 4. Instead of writing the function, we'll be writing the main algorithm of the program. So we are given the crc.h file. So in this lab, we are writing a client for crc slow, calculating the crc for a message, changing the message, recalculating the crc of that changed message, and appending the crc to the message so it's ready for transfer. In order to start, we need to include our libraries. So we include the standard.io file, which lets us print to the user. We're also including string.h, which allows string manipulation, and we'll be using that to simulate appending the CRC. We include the standard library, and we need the crc.h file because that's where the definitions are. We are also defining CRC size, which will be used later in the code. But it's a constant, which allows us to update easily if we ever need to change it by just changing one single value. So in the main, we need our inputs, the message, n bytes, and n bytes is the length of the buffer or the message. So here I made up a random message, and for n bytes, we can count that message, or we can use a string length function to do it for us. Then we need to get our outputs, which is CRC, and we can make up the variable which we named calculate CRC. So in order to calculate the CRC, we need to look at our crc.h file. Because we know that we are using CRC 16, we know what the CRC size should be, which is 5. So we can calculate our CRC. We can look at the crc.h file again and see what the inputs and outputs of CRC slow are. So in CRC slow, we still need the message and its length, which again is n bytes. The sprint f allows us to print the calculated CRC, which is an unsigned short, into a string. So now that we are able to find the CRC, we now want to append the CRC to the message so it is ready for transfer like the lab asks. In order to transmit message, we need to make a longer string, which is what this line does. We do this line because our message is as long as it can be, so we need to transmit message size. So to transmit the message, we need to malloc it, and we use malloc because the malloc function allocates the requested memory and returns a void pointer. So in order to get a char pointer, we need to cast it. And we do this so that we can skip through it and know how many bits to move forward to the next character. So in C programming, the string copy function copies the string pointed by the source to the destination and returns the copied string. So we use this because we want to get it into position by moving the message to the left side of the transit message to use the string cat function. The string cat function concatenates or joins two strings together. So we want to join the char message with the CRC. So we perform 1, and this here lets the user know that the last 4 characters are hex. And because we added the hex identifier, we had to add 4 to the CRC size because a space is 0 and x and another space takes up 4 characters. We just do this so that we can distinguish between the message and the CRC. So now we want to join them into the result string. Then we can print out the results. And the next part of the lab requires to repeat this by first changing a bit and then recalculating the CRC. So we can put it in a loop it however many times you've created a change, in this case once. So we will loop it twice, and the loop performs the CRC calculations 2 times and prints it out. This here changes the message. So now we can run the code and see that in our first message displays the message and the CRC in hex, and then the next line reprints the message but with the zap bit, so which is the change, and displays the CRC in hex again. So that is Lab 4.